And this is a common scenario that our steel-faced insulated panels are joined with aluminium angles. And the scenario is such that when you're transferring load from the ceiling to the wall, uplift on the ceiling will put the ceiling rivets in tension and the wall rivets into shear. Similarly, shear in the ceiling will put the ceiling rivets in shear and the wall rivets in tension. So depending on the scenario, your rivet will either be in shear or tension or both. So in other calculations, we have derived the forces within our rivets, but due to the load applied to it. So in our case, we've applied a tensile load of 1 kilonewton per meter and a shear of 1.5 kilonewtons per meter at this junction. So turning first to the aluminium, we're looking at mechanical connectors in clause 5. We pull out our strength reduction factors, put in our basic information like the diameter of the fastener and the spacing. We pull out, this kind time is just for one of them. So one sheet, one element is aluminium, and here are the bearing and tensile strengths given by the code. So our angle in this case is 1.5 millimeters thick. A quick check on the minimum spacing and edge distances. A check on the bearing, which we've seen before. And we compare the bearing capacity against the applied shear and against applied tension. Then we find out the capacity under tension. So we have our design tension capacity, not spelled correctly. And then compare it to the applied tension force and the shear force. We've also already put in the spacing of the bolts. The SF is the spacing of, the rivets. Then look at the shear loads that you're applying and the shear capacity. So you're looking at the shear capacity of the rivet, and it's not usually the rivet that's a weak point, but it's worth checking. Then we go on to the other component. Well, it's cold form steel. In this case, it's grade 300. And you're looking at, again, 4.8 millimeter rivets. So you've pulled down the diameter from above and the spacing from above. And you're looking at the thickness of the sheet. In this case, it's 0.55. Again, a check on the minimum spacing and minimum edge distance. Looking at the tension in the connected part, and you're subject to shear. So you apply those, again, compare them with the applied loading in tension and shear. A check on tilting and hole bearing. And it's a complicated equation depending on whether your T2 over T1 is less than 1, then you get 0.54. If it's more than 2.5, you get 0.94. In our case, it's less than the 0.367, so therefore you're using the first value, even though I've put in the potential for interpolation in there. So our utilization has come through. In shear, it's 82%, and bearing against tension, it's 55%. If you're looking at limiting by end distances, here's the equation from clause 5.6.2.4. And a quick check on the rivet, again, just the rivet itself in shear, not normally a problem. And those are the references. So leave a like and leave a comment and subscribe to the channel. I see from the analytics that my second biggest audience is in Hong Kong. So welcome if you're watching in Hong Kong. If you have any comments, just putting in the comment section under the YouTube video.